Okay, okay, finally. Sorry about that. Okay, let me just paste this. Where's the chat log? Um, Chat. Okay, so can everyone hear me? Okay. Okay, so today we will start our class, and I just paste the URL on the chat log. Not sure if there's any sound there. Hope there are. Let me just check my settings. Okay, remote audio. Okay. So so there's like a test this weekend. If for those who are interested in taking, uh, basically you have to register with ProctorU. I think you have to register with ProctorU, and in fact I believe I have some instructions written. Let me just pull up one of the instructions I had. Let me just check this one. Are you able to see the screen or no with that URL? Hello? Okay. Okay, that's good. Which glitch? This one, scene. What do you mean, loop? What happened? Oh no, no. I mean, this. It should capture the screen. Because I'm actually doing this remotely for some reason. OBS doesn't seem to work on my computer. It's not capturing correctly. So I'm just doing it remotely to my office computer. Are you able to see anything? Let me just double check. I haven't checked that one. Let me just check this one. First video. Live. Is it okay now? Like, I think it's okay, right? It's like, I think it's okay, right? Hmm? Okay, it looks fine. Okay, so we will have a test. It's a little bit different than most of you who have, have taken the test before. Let me just copy to 5430, browse. Just gonna copy into the info section, and also, yeah. What link? What do you mean? The stream? This link expires? Okay, I see. Yeah, hold on. Yeah, sorry about that. Let me just get another link here. I thought I copied it. This is okay. Let's see. Um, videos, live. Seems like. Oh man. Live. Okay, copy, paste it. Oh, okay, yeah, I must have copied the wrong one. Okay, so okay, so if you look at what is it, Blackboard, right? So go to your Blackboard and check out the course. So for those who are taking the second test, we will be having one. I set it to 200 minutes, and ProctorU is not free. However, on the school is actually the heck. Didn't I just copy it? That's weird. Let me just reduce this resolution. I thought I copied it. Maybe I must have copied to the wrong one. Okay, let me just undo it. Okay, let me just copy again. This, oh, sorry, I copied to fall. Spring 20, browse, information, submit. Okay, let's copy this one, I believe. Spring 20, this one. Okay, and then browse information. Okay, so if you go into like the Blackboard under information, yes, it should open up automatically. So basically you have to like create an account and log on. Once you log on, I believe you search through search for my name and the test, and you have to register it. But they said like I think 72 hours within 72 hours of the starting time. Um, well, so the deadline is like 3 days before the test. Afterwards, there's going to be extra charge, but I think the school is going to handle all the costs. I'm not sure how it works. This is the first time we're using it. So if you log on, you'll see like some exams, and it hasn't been improved, I guess. I'll have to wait until it's getting improved. I just submitted a request today. If it does get approved, I should be able to see it here. And you'll see like ISAM 5430, Spring 20 final exam, test 1B. Hopefully it will get approved, and so the goal is for them to proctor the exam. Uh, you're going to work on Visual Studio, and I'll be providing you instructions at exactly 1 o'clock p.m. on Saturday, and you'll get. I'll also post a video um, along with a section. So it's going to be on Blackboard, and everyone can access. But in order for me to know that you have taken the exam, is for you to sit and proctor you. The test is set to be 200 minutes because and you're pretty much on your own with the test. So so let's see how everyone does it. People who are interested in pulling up their grade, and I'll try to make the test. The test I've been thinking is going to be based on the homework assignments, probably 3 problems, easy, and then mid-level, and then a little bit, and then well, 2 mid-levels and 1 easy problem. Focusing on the homework assignments that we had before on arrays and methods. Questions on the test? Yeah, unfortunately. I'm not sure how that works because Proctor U, well, that's unfortunate, and most of the time, um, yeah, that's unfortunate because mm, I'll have to contact Proctor U and see how that goes. Maybe there's like a possibility of doing a chat, but I doubt it. I seriously doubt it if that's possible. So I'll have to figure this one out. If not, I'll make the test super easy to understand so that you won't have any questions. And if you do have questions, it will be mostly like your issue in your coding ability. The test is going to be mainly like the first test, except we're dealing with a little bit of arrays and methods. Yeah, around two mid level. Yeah. Um. So I believe that's possible because that's the way they have it. They have like a screen recorder, so they require you to install a screen recorder, and your laptop cannot be Windows S mode. It has to be Windows 10. Or I think they also have a Mac version as well. And then so they basically have to record your screen, look at your camera to make sure you're not communicating with other students. The reason I'm making this way is because this test has to be proctored, and I was hoping that for those who are interested in improving the first test score, which I promise, uh, you can't like I'm giving you like a second test in replacement of the first one. So I'm not sure how this will turn out. If it doesn't work out that well, I probably would just curve it, but hopefully it will be a lot better. And in fact, I can even probably use the same problems from the homework assignment, or just modify a little bit so that so that your practice will be on the homework assignments that you had before on arrays. Um, yeah, I'm not sure. I think well, just log in with your UHCL email address so that they know, and then This one is set to like reimburse from the College of Business, so they're actually the College of Business will actually pay for your exam fees. Otherwise, it's going to be like for 3 hours. I think it's going to be like $40 or $50. It's pretty expensive, but the school will cover it. I'm not sure actually. I don't. I think when I put because I have a category set that it's College of Business institution paid. Let me just double check my emails to make sure they're not returning any like replies, anything. See if I got anything in my email. Um, yeah, I don't see a Tuesday 3/4/3/24. Let's see. Uh, no, I don't get anything from Proctor U. So they're still on the review. I just submitted like too late, like 10 o'clock. Usually takes a whole day of meeting of approval. So we'll see what they said because this is probably they've done like proctoring, like basically like Blackboard multiple choice questions exams, but in our case it will be more of an application that you have to open. Uh, so I'll have to see what they have to say about. Um, any other questions? Oh yeah, you can. Yeah. No, no, no. It's just an account registration, just like Facebook or any other sites you use. Okay, so yeah, so we're gonna have Proctor U test. Hopefully it will be okay, but I don't know. It's unfortunate. So everyone is feeling okay, right? Huh? Yeah, if it doesn't work fine, maybe I have like an alternative solution, but you don't have to worry about it. If you didn't do well in the first test, you got like 60, 70, 80 or whatever, or 30. Um, so you don't have to worry too much about like having that being considered in your grade because at some point of time by Saturday, you can expect that there is something that you can make up for that score. Yeah. Because unfortunately, if I make this take home, I realize either I have to come up with like a lot of different problems, or people are going to give me the same solution, and eventually I don't want to give everyone zeros, like just discard this test, and I know it's going to happen, uh, because it has happened in the past. So so I'll try to think of something else if it doesn't work out. But Proctor U will be the best choice for now, and I'll keep in close contact with them to make sure what we can do and what we cannot do. Any other questions? I know everyone. Well, I know everyone is worrying about this coronavirus COVID-19, right? Yeah. How many cases? 140, right? And China is still in the 80s, right? 80,000. And then, oh wait, I don't want this one. So, Oh, 150 already. Yeah, I think yeah, so they're not so these cases unfortunately like our president does not want to force a lockdown on the whole country because I think that's going to happen. Otherwise, the numbers are just going to keep on increasing. And China has already confined the Wuhan area, and that's why it's still like 80,000 for the past whole month. But USA did not huh? Which one? Yeah, yeah. So a lot. So it means that they're not getting any new cases. But unfortunately, the USA well, China was forcing to lock down everything once they reach a certain amount of people, but our president doesn't do that, and he kind of refused to do that. I don't know why. Like New York City should have been a lockdown, and right now it's still partial lock. They're not like forcing everyone to they're not like really forcing everyone to stay at home, so people can actually still roam around, pass virus everywhere. But they're still um, so they're still like social, like so all the social gathering is still out, but it only helps a little bit on the situation, and these number, the new cases obviously probably came from like the time before, like 2 weeks ago, before anything was forced, like anything that they put into play. Yeah. Which one? Yeah. Wait, something's wrong with my speakers. I don't know. Okay, yeah. So I hope it will get better. So I guess everyone here is staying indoors, right? What happened? Yeah. Oh yeah, yeah. Yeah, Houston area was actually having everyone to stay at home. Um, so let's. It's really bad. Um, I don't know, like especially right now, everyone has to study, and uh, kind of feel bad for everyone. Like maybe there's a better way. But unfortunately, for classes, like you came to the USA, uh, and things are getting worse. And India, I think it's still pretty low. Yeah, probably you're probably a lot safer there than here. Okay, let me see the stuff here. So last week, let me just do this class 8. So maybe like this week, I'll just let's see how does it work. Assignments, just for practice. Um, so this is actually from last week. We did like a basic C# syntax on class um, ID, and all these codes are have already been uploaded to GitHub, so you can actually review there. So we did like the fields, the data members fields, the constructors that in general initialize some of the data members, and we did methods and properties, the get and set properties. Destructor we or finalizer we summarized it before, and of course we focused a lot on the methods as well earlier. So we have two types of members. One is the data member. The other one could be so the other one is the auto implemented property, and I'm not sure if I have it here. Yeah, I don't think I have it here. So two types of data members. You have either field or auto implemented property, and operation members can include um, properties as well as methods. So those are the basic stuff, and then we also have constructors as part of the class members. So that's all we did last week. Let's go over like chapter 11. Let me see if I can just pull up PowerPoint. Not here. I don't even remember where I put it. Come on. Okay, so this one, Google Drive. Okay, 11. Okay. So we're on to chapter 11, which is about inheritance. So the idea of inheritance is to bring the common features from another class into one class. So that's what we call so that's what we also call inheritance, and also deriving a class. Okay, this computer is very slow. Let's actually trying to source. Okay. Okay, good. Okay, so in general, inheritance is also known as a relationship. For example, vehicle can be a class that can be like uh, a car or a truck, and therefore a car is actually a vehicle. A truck is also a vehicle. A truck, for example, has a bed. A car perhaps has a trunk, right? A vehicle does not necessarily have a trunk and does not necessarily have a bed, but a vehicle can accelerate and also can move, just like how a car as well as a truck can also move. So the car and truck may move at a different speed. Uh, that the speed like the speed can be defined the maximum speed a car can move. So basically, each vehicle can have a specific the maximum speed uh, that a car can move. So for example, if we try to build this class, right, we will have let me see if this is downloaded. Okay, so for example, if we have a class, right, let me just open this seal then. Okay, so I'm opening Visio to just draw some diagrams. So let me just do UL class diagram. So here we have like a class. Just shrink this. Okay, so we have a class called vehicle, right? And then we also have also have like another class called car. So in the car class, it can have let's say max speed, right? So this could be like maybe a property, right? And let's say we also have accelerate, right? So let's say we have accelerate, and we can also have maybe another field called hmm, batteries. Oh, sorry, it's battery charging. Okay, this is so weird. Okay. Uh, yeah, my battery just went low on this laptop. Okay, so So we have a truck. So here we have we can extend uh, actually what? So we have a truck. Truck also has this kind of property, right? Um, and they could have like different stuff. For example, a car has a trunk. A truck has let's say bed. So they have two different things. Uh, what they have the same are the maximum speed as well as maybe accelerate. So what happens is that these maximum speed are going to be the same kind of structure the car and the truck has, but they may have different values. Likewise, the accelerate. Uh, so a car can accelerate at a different speed as a truck, but so it means that the overall operation could be different. The overall operation could be different. Like the car may have different kind of acceleration, and the truck can accelerate a little bit differently. And we can also add like uh, let's say we call move, right? Another one we call move, right? So in this case, both of them are going to move, but the distance the car is moving is based on how the car accelerates. In other words, if we look at these two different classes, we have they have the same structure but different data. So basically, both of them have the same feature. So according to our commonality analysis, we can combine both of them into the same structure, which we can call the vehicle. So in this case, the vehicle can have a maximum speed. A vehicle can also have can also accelerate, right? Can also move from one point to another point. Spam. Okay, so in this case, we can say that a car is a vehicle, a truck is a vehicle, and a vehicle has max speed, can accelerate, and can move from one point to another point. Now, going into inheritance, we have this symbol, which said that a car is a vehicle, right? And when we look over here, right, a truck is also a vehicle. In this case, okay, it looks weird. Okay, whatever. So a car is a vehicle, a truck is a vehicle, but now we have some of the stuff here, right? We have max speed, right? Max speed, right? They both have the same structure, right? But different data. So in this case, we can easily update the maximum speed with the different data for the car, right? So now, because they have the same structure, the car and truck does not necessarily need to have the data member max speed. Now, if you look at truck and bed, these are different, right? These can be a property or method, however you're designing your truck or car. But the point is that since they're different, both cars and trucks will have these members. whereas a vehicle will not have that kind of member. Now, if you look at accelerate and accelerate, they have the same structure. Both methods are the same, or both operations are the same, but they have different implementation, which means that this can be defined as what we call an abstract method. So let me just italicize an abstract method, which means that this method only defines the structure or the header, accelerate, whereas the car and truck now implement the accelerate function. Well, for move, right, for example, this function, right, basically just use the accelerate function and move the vehicle from one point to another point, right? So it's possible that the vehicle can implement the move function, whereas a car, right, and truck can also implement it, right? If they implement the same function, right, they're overriding. So basically, the car can override the functionality of the vehicle's move function. Or they don't have to override it. They can also use the vehicle's move function. So if they don't override it, you don't really need it. So for example, like here, you can have you can override let's say a two-stream method, as you probably have used it before, right? So now vehicle two-stream method can override, like vehicle overrides the two-stream method, and this two-stream method, on the other hand, is defined on the object member, object class. So let me just create a system class, right? So this is the system.object class. Every single class extends an object class. So in this class, you have basically the four functions that everyone should know. ToString basically implements the returns the fully qualified type name of the class, and the next one is the get hash code, returns a 32-bit integer that represents the hash code of a class. And then we also have we also have let me just get rid of this. We also have a couple of other like equals, right? Compares the reference of the two references. So this one, the equals could be like an object other. So you have this and other. Then we also have what's the other one? There's a fourth one. Equals get hash code toString, and what's the other one? I don't remember. So let's look at system object, right? Here we go. Okay, so methods. So these are the stuff that oh yeah, get. So and then the other ones we don't really use it that much. So these are the four important ones that you should know. After, so we have a get type method, returns the reflective type instance of the current instance. Yeah. Okay. So we have like four different classes, and the toString method. These are actually the default implementation of these members. Get these. We also define what we call the virtual method. So what virtual method in C# allows you to have is that you can like the implementation can be overwritten. In order to overwrite the existing functionality, you have to declare a virtual keyword before the member. In Java, every single method is assumed to be virtual unless you have the keyword final written beforehand, which means that the implementation of the method is sealed, that cannot be overwritten in the derived class. But in C#, the default method is sealed unless you put the virtual keyword before the method, whereby allowing you to overwrite the method in the subclass. Is everyone understanding this part? The concept? You can chat. I don't know. If you don't want to say anything, just write on the chat log. I just want to make sure if anything it's not confusing or anything that needs to be clarified. Yeah, I will. But I want to because the most important part for classes is to understand the concept. Because without understanding the concept, you're just seeing like blank codes. Because I really want you to understand how you can relate the codes into like real life examples, like how you visualize in your everyday job or work or stuff. So that's the basic idea, right? So this means a vehicle is extending the system.object, and the car extends the vehicle, truck extends the vehicle. I can show you like a more abstract class, right? Let me just see if I have. Where is it? View, Team Explorer. Where's Team Explorer? Hopefully I have it here. I don't think I have it here. Let me just go to so GitHub.com. This one. Clone or copy. Copy here. And then let's add a new one. Now clone it. Clone. Takes awfully a long time to do it. I should have done that earlier. And realize. Okay, good. Okay, let's go here, and then I'm going to create a new solution. ISAM 5430 SP20 class 9. SP20 class 09. Let's enter it here. Okay, let me just pull out a more abstract thing. Class 8. Okay, so here's like a more abstract way of writing it. So let's say we have the base class, right, called A, right? Okay, so I have a base class called A. And here, so as you know, class A, right, extends, every single class in C# extends the class object. If you go into object, this object is essentially the same as system.object, which is what I wrote. So essentially, this object is the same, exactly the same as system.object. If you go into object by pressing F12, you will see that they have the functionality that we have all the virtual methods. So equals, and then get hash code, type, toString, and then they also have a member-wise clone. This one means it's a shallow clone of the current object. But these are the four methods that you should know. At least you should know all these virtual methods. Equals get hash code and toString. When we talk about collection, these two will get very important. The equals as well as the get hash code when we go into collection. That's when they become more significant. So get hash code basically identifies the object from a collection. It identifies with a 32-bit integer, so they're supposed to be unique. But if they're not unique, that means that they have to be checked via the equals comparison. Okay, so in this case, we just wrote class A object. Then let's give it a name. So I'm going to define as public string name get semicolon. And basic idea, right? We're gonna introduce let me see. Yeah. So we're introducing like a constructor, very basic constructor. So this constructor will say where we just simply want to write the A, right? No, actually, you know what? Sorry. Yeah, so basically we want to say that we just want to print out the bracket A, right? This one, so basically what I did is that I represent the bracket A as what when we call a constructor. And then we can also call a second constructor. This is an overwritten one, so I have a name equals a name. And in this case, I'll just simply write console.write bracket A colon name, right? Oh, shoot. Double quote bracket A colon name. Okay, then we can move on to writing, let's say, virtual. So right now I define the keyword virtual. This means that we're going to define the method x, right? So in this case, we're not really referring to anything real world or real life examples. We're not doing any examples. This is more of an abstract example that we can infer from us without like referring to the actual examples. Hopes this will help a little bit to understand this. So in this case, I can call I define as console.write a.x, right? So this one tells me that I'm invoking this method, and then this is going to be this console.write is simply the implementation. Next, next, public void y. So this one will simply just have write a.y, and then this one I can overwrite the. So there are three methods that I can overwrite: equals, get hash code, and toString. So I'm overriding a toString method. So this allows me to return a string version of A. By default, it calls a base.toString. So what this one means is that it's calling the objects implementation of toString or base toString. But we want to override it, and we call A class. Okay, so this is like a very basic example in which I show you some this is what we call the read-only properties, where you are allowed to set the value of name directly into your property from the constructor. Okay. Yeah, what about second constructor? Oh, yes, correct. Yeah, we can have a dollar sign, or actually we don't really need it because the goal is to show you what exactly is the display space after. So the goal is to actually show you what exactly is it working. So let's test our function. So we can simply test it in our program. In this case, we're going to define A, right? So let's define A. So A is lowercase a equals new A, open parenthesis, close parenthesis. And now we can simply write, let's say write line A dot, we have a few things here. So let's do A dot name. Right, this is essentially going to be an empty string. And we can also do do print console.write. No, not console.write. We can simply also do the just call the function, right? So a dot x, right, and or a dot y, right? We can also print. Sorry, it's lowercase a. Okay. So basically what this one does is that it's going to print a.x and then a.y, and then let's also define another one called a.aa, right? A1 equals to new a. Let's define the name, right? So let's say Mike. So the name is now Mike, right? And we can also print the same thing. So everything here is going to be the same, right? We're not changing much here. So you're going to see a.x and the a.y, right? So when you run it, just lock this. Okay, so you see like we have A, right? This is the constructor. Then nothing is going to be printed afterwards because the name is empty. But now we have A dot X bracket. Oh, sorry. So A1. So all we are doing here is to add a constructor and you see the mic and then A.X, A.Y. So everything here is fine, right? Everyone understand up to this point, right? This is a quick review of the last week session. And then when we move on to inheritance, so now I'm moving on to inheritance, adding a class B. So this class extends A. When B extends A, right, as you know, since A extends the object by default, B also extends the object. Defining the constructor, public B, open parenthesis, close parenthesis. This is a constructor. By default, this constructor calls the basis constructor, the basis parameterless constructor. So by default, it's actually calling the base, open parenthesis, and close parenthesis. What this one means is that the B is calling the default or a parameterless constructor of A. This is a syntax in C#, the colon base. In Java, it's actually written like super before everything else. But in C# they force you to have like this. I think it makes more sense in C# than Java because in Java it kind of like your codes are actually kind of like in the beginning of the constructor, and then you can't write any codes here. The compiler will give you a syntax here if you try to do it. But in C#, you can you need a colon and then base. So in this case, we are going to simply write console.write. So let me just remove this line by commenting it out, and I'll show you like it's going to call a base constructor by default. Okay, and then if you go to B, string name, right, we're doing the same thing. And this one, by default, it calls the base constructor. It does not call the string name. It does not call a string name. In order to call a string name, you have to define the base constructor calling the name. In this case, I can simply write console.write bracket b colon, let's do the same thing, name bracket $. So as you know, the order of execution is that it's going to call a name first, the constructor and a name, and then it's going to implement this implementation here. Next, let's override. So by overriding, it means that we are overriding this X constructor. When you override, so when you write override, right? When you write keyword override, I think it should autocomplete. For some reason it's not autocompleting, but I'm not sure why. So public override void X. Am I having yeah. Oh yeah, sorry. This one, for some reason I put outside. Okay, so if you write, yeah, so you can only override a virtual method or an abstract method. So now, so in C# it forces you to specify the virtual keyword before anything you want, any method that you want to be overwritten. But in C# you are also forced to write down the keyword override. You have to write down the keyword. If you don't write down override, it's going to give you a different type of stuff. I'll show you soon. Okay, then in this case, let's write the public void y. Okay, so notice. Let me just write down this one. We're gonna change it. Console write x dot no b dot x, right? So I'm putting in space here, and then here we're simply just gonna put b dot y space. Okay. So this was when I don't have my override. So what happened is that it's going to hide the inheritor member y. But I'll show you like actually, you know what? Let me just get rid of this one first because I can modify it later. Okay, so now let's define everything again, but this time we're going to start with b equal to new b, and then we're doing the same thing, right? So everything here, we're going to repeat the same step here. So here we have b dot name, and then b dot x and b dot y. Likewise, we also define this is actually b. b1, b1, b1. Okay, so now we have a few methods here. Right? So everything here. Let's actually do a console.write line here. We're gonna console.write line everywhere else. Let's put a console.write line. I'm changing a little bit of stuff here. Maybe I put like console.write. Let's put like name is curly bracket, curly, and then this. Okay, so this is gonna be B, and this is gonna be C, B1, and okay. So we need a console.write line here. So basically what I'm doing here is that for each line it's gonna be an execution. Okay, so what I did here is that the first one, it's going to create a new instance of A without a name, and then calling the name X and Y, and then write a new line. And then the second instance of A created with the name of Mike, printing the name X and Y as well. Third one is going to be the B, created with a name, print X and Y. We're repeating this again. A new instance, but this time we need a name, right? So let's call a name here. And then B1 and B1. So print out the name, X and Y. Okay, now when you run it, you'll see 4 lines. The first line, hold on, let me just check. Oh yeah, this one I need to replace that line with A. Okay, so you're gonna see 4 lines. Man, keep on. Okay, let's try this again. Space after every single lines so that okay, so that we have some separator there. Okay, so here you have A. The name is something, right? This is an empty string, and then we have AX and AY. So basically we discussed that part. So the second one, call the constructor with a mic. The name is Mike. AX and A. Now for the second part, right? This is now we're creating a new. So for this one, we are creating a new instance of B, right? Those are what the brackets mean. But as you know, when you call like a B here, just pull over. So when you call the B, what's going on? Okay, so when you call the B, right, you're you're invoking this method B, the constructor B, right? But this constructor is going to call the A constructor first. So this will invoke the A constructor, whereby printing out uh, the A bracket A here, and then it's calling the B constructor next, which is this line. Afterwards, we're printing the name. The name is, then it's calling the beta x, right? So beta x is this part. It's calling the beta x, and also it's calling. It's going to look for y, but y does not exist here. Notice I comment out these lines, but since it doesn't exist, it will use the from the inherited class, the class that it extends from the A. So A has to find the y, and that's what you see here. So this is calling the A dot y. So we have beta x. This one's the overwritten method, and A dot y is calling the basis y function. And now we're doing the same thing for the name, right? But in this case, by default, it's actually going to call the name here, right? But what we're doing here is that we're taking this name and passing into the base constructor with the name value in. And this function itself sets the value of name, capital name, to a name. And now in this constructor, we're not doing anything except we're printing out its location with a console write b name. And finally, the name is name, right? So as you can see, the name has been set. It's pulling from the parent element. These two are the same, b.x, a.y. Now, the override is actually required. So let's say if we change this to a, right? A. So in this case, we're assigning this b, right, into a variable whose type is a. This is allowed in C#. This is what we call covariance, which means that it's an output. That means that we're allowing to set a class to a superclass here. When the variable sets to a superclass, and that's what we call I think covariance. There's also contravariance that's applied to the input. In this case, since B has less feature, supposedly has less feature than this capital B. So this A has less feature than B, right? So we're not actually going to, the variable B is not going to have the features that are introduced in B. in capital B. So for example, if you have a new method called Z, right, and B, right, in this one we're just simply print again B dot Z, right. In this case, when you do A, B, right, even though the instance has this member Z, right, you're not going to be able to access it directly. So in this case, B.Z is actually going to give you a syntax error. Even though Z is actually defined, but what the execution sees is that B is an instance of A, and therefore it does not, and since A does not define the member Z, this B does not have it. So in this case, since X overrides, since the X in B, capital B, overrides the A's X, now this new B, right, this instance of A, right, will still use the same implementation of BX, right? So if you run it, you still see the same implementation, the same output. So it will show you B.X, not A.X. Yeah, I don't know why is it. Hold on. Let me try to run this again. Oh, because I'm selecting. So what's the question? Well, in that case, it's going to give you a syntax error. So, for example, if you want to set this to B, right? This is actually a syntax error. The reason is that B has more features than A, right? How can you, like, what's going to happen? What happened to this? What happened to this Z? If you create a new instance of A, right? Since A does not implement Z, right? What's going to happen here? You can't put like something that's more general into something that's more specific. That doesn't really make any sense here, right? When you create a B instance from a class, well, because I don't quite understand that. Well, what do you mean by that? Yeah. So here, so let me repeat this one. So this one is we're creating a new instance of B, right? And we're setting it into the variable B, which has a type of A, right? And what's your question? How do you call the base class constructor? So here, B, right? You're calling B, right? The first task is to first invoke the base class constructor. But here you cannot call the base constructor directly. It has to go through the constructor that's defined in the class that you're creating a new instance of. So you cannot really call a constructor directly. So in this case, you're creating a new instance by invoking this constructor B, and this constructor automatically calls the base constructor, which is the A constructor of the default or the parameterless constructor here. So this constructor calls first, and then it exits out that constructor and calling the actual constructor in B. Yep. So for example, if you have like three classes, let's say you have a C class that extends B, right? So what happens is that the C class, right, will call a base constructor, which is say B, the constructor in B. Then the constructor in B will also call the constructor in A. So indirectly, constructor in C will call the constructor in B as well as A, but it's actually calling because the B constructor is calling the A constructor. That's why the constructor in C will automatically call the other two constructors in A and B. If you create a new class that extends B and that extends B. Right, so in this case, if the constructor in C will call the B, and B will call A, and therefore you're calling this way. But in C sharp, you cannot skip any inheritance. So you cannot for example, you cannot call like a I guess the grandparent of C, right? C cannot call A directly. It has to go through B before it can reach A. And that goes for constructor. For methods, it doesn't really call for methods. For X method, it doesn't invoke the base method at all, unless you tell it so. Unless you have you have something written like this, base.x, which will call the base method x. But in C sharp, the method doesn't call the base at all, unless you specifically wanted to. Is everyone clear on this point? Is everyone around? I don't know. I am not hearing anything. I don't see any chat logs. Yes? No? Just one person out of 14. If this is in class, I'll be able to see who doesn't understand it quite easily. Okay. Okay, so let's see why this override is important here. So let's say I got rid of this override. Okay. So let's say you missed it, right? So now you have a green squiggly line. And in the test, I urge you not to see any green squiggly line. Just make sure that you don't have any squiggly lines. The red ones means syntax error. The green ones are warnings that you should avoid as much as possible, because sometimes warning can result in logical errors. So when you run it, this is still the same as before, right? Notice I just have b equals new b, right? This shows that bx and ay, right? So what happens if I miss an override? So the difference is when you actually force b to have a type of a, right? Now you see that instead of showing you b.x, right, this is now showing you a.x, not b.x. The reason is that in this case you are not overriding the method x. You're creating a new function of x under b, and when you set it to type a, it's not you are calling the a's x still exists for that you can call. So you're not actually overriding the function. But when you change this to override, then that becomes a different story. So b.x, a.y. This becomes necessary. Like, why would you want to do it this way? Why don't you do it with b? Why do you want to make it a all the time? I mean, what's the point? The reason is that sometimes you do not need all the features in the subclass in the derived class. You don't need it, and therefore it makes more sense for you to use to just pass to just specify the base instance instead. So in other words, you don't want to pass like whatever that's well, so sometimes it's not helpful to have more features than less features because you don't need a lot of features. That's why in I guess in Microsoft Word or any programs they don't expose all the features for you, but instead they show you a little bit of features, and if you need more features you customize it so you can show a lot more features. And this goes the same for application programming, and it becomes more prevalent in functions. Is everyone clear about this part? Okay, so that we talk about virtual, and then virtual and the override, and also in C# there's also new, right? Keyword new. By default, if you don't have an override, this becomes like a new function. You're creating a new function, and that's why when you have a public void x, the default implementation is going to be new instead of override. So they tell you to use either have an override keyword or add a new keyword. So make sure you pay attention to these green squiggly lines. There's also something called sealed. Right, so in this case, do I have an error? See, yeah, I shouldn't have an error. Okay, so in this case, I'm overriding x, but I'm making it sealed. Without a sealed, right? Sometimes you don't want like a subclass to override the stuff that you have already overwritten. So in this case, if I write public override, right? So you can see still you can write an x, right? But if you make this a sealed, right, it just means that you're blocking this method to be overwritten by the subclass. So in the third class, if you write public override, so you can no longer override the x at all. So this will give you a syntax error. Of course, you can create a new function of x. Of course, you can create a new function of x, right? So you can write sealed, new. But that's not overriding the method in B. Now, so that's what sealed means. It means that this member has been sealed. In C#, you can also do a sealed class B, right? This means that the class is now sealed and it can no longer be inherited. You cannot extend B anymore. And then you also have what else? Okay, and also like when you override a function, everything has to match, including the access modifiers. The access modifiers must match. So for example, you cannot write a protected override when the base class defines the base class defines a public override, the public's virtual method. So it has to match perfectly. It has to match exactly. So there are 5 access modifiers. Let me just write it down here. So there are 5 access modifiers. So we have 5 access modifiers. What are the 5 access modifiers? So we have let's write private first. No, actually let's write public first, right? So you have protected and you have private. I'm gonna label the stuff. I usually like to label it 1, 2. Actually, you know what? 2 and then 4. Okay, there are 2 more missing. So public, then we have protected, right? So this is actually 3. And we have internal, and then I like to write protected internal. Okay, so public means that the member can be accessed anywhere, and then protected means that the member, what was it? Can be accessed there. Yeah, and within the in not the class, but in the let's say the derived in the class and the derived class, and this one is within the member can be accessed within the current class. Okay, then we have something called internal, right? Internal means that the member can be accessed within the assembly, and this assembly in Visual Studio means the project, within the project. So each project, when you compile it, it becomes either DLL or exe. The DLL file becomes an assembly, exe likewise. So it just means that the member can be accessed within the assembly. And protected internal just simply means that the member is either protected or internal. Not and, so it's or. Either protected or internal or both, whichever. And right 1, 2, 3, 4, right? So this has the highest level, right? So it means that this it means that the private member can access anything above it, right? Internal can access anything above it. So internal, like level 3, can access protected as well as public. Internal can access protected internal or public. Protected can access protected internal or public. And then protected internal can access anything that's either protected internal or public. So this is the access levels, but it's possible that protected, some members of protected cannot access the internal or vice versa. And this becomes important when you, especially when you try to write function like this. So this becomes, so if you write something like this, right? If you write this, so by default, this class A is internal, right? So internal is level 3, right? Which means that if you start writing, if you start making this function, I think, let's see, public class, internal class A, and if you make this, wait, that's not right. I thought like an, but anyway, like uh, by default, the class is set to internal. But if you want this class to be accessible outside of the project, you have to define this public. That's why you see my unit test cases. I always put a public before the class, because otherwise, class is treated as an internal class. Likewise, if you don't have a public here, this member becomes a private name, a private member. That's why you always want to add access modifiers. And I take off points if you miss an access modifier, because I want to see you putting access modifiers everywhere else. Okay, so 3 o'clock. Okay, then we have something called inheritance. Not inheritance. So we have like new types called interfaces. So I'm just going to go over like chapter 13 as well. And then next week we'll just start with chapter like the end of the chapter, because I really want to like be able to help you relate between real like a real world scenario as well, and also like the OOP. It's not just about like writing codes. It's about like how you can relate them together. So let's talk about interfaces. So in interface you have let's say so let's say you have an interface. I call like interface whatever. So this interface is gonna be has a keyword called interface. So what interface allows you to have are different types of members, and the members that are allowed are properties and methods. So anything that involves with the operation members are allowed. So interfaces are also abstract, right? So when I say abstract, it means that you are only defining the headers, but no implementations. So the implementations will be the ones that you are implementing the interface, or implementing the abstract members, any derived classes that implement them. So let's give in like a few examples. So let's say I have name, right? String name, get. So in this case, I'm defining a get property that has a return type of string with the name of name. And all the interfaces are public, just like let's say USB, right? USB is an interface that you plug into your computer. It's not supposed to be hidden from people. You can just plug in, let's say, a hard drive or a printer to the USB port, and your printer will be able to print out something. You'll be able to read something from your hard drive. And they mostly are public members. And you can also do like you can also do methods here. So let's say display. So this is an interface, right? So you can, operational members, you can have all the operational members that includes methods and properties, but no implementations. Okay, so that's how we define interfaces, but let's try to implement our interface. So the way that interface works is that you can implement to a class. It has to be implemented to a class. An interface can also extend another interface. So you can have another interface that extends this interface. In this case, when you want to implement an interface, you simply add a comma after the A. And a class can only have one superclass or the base class, but it can implement multiple interfaces. So I have a red squiggly line. In this case, I can simply fix it by moving my mouse over and selecting this implement interface here. Oh, what is this thing? I have no idea. And when I try to implement it, wait. Wait, what? Where is it? Oh, display here. So I have a string name. The name is actually already implemented in the base class, right? In A. So it's already implemented here. I already have it implemented as a read-only property. When you have properties, right? This can be either an auto-implemented property when you implement an A or in the derived class, or it can be an implemented property. It's either one or the other. Okay, so now let's say print B, right? Whatever, I'm just going to print B, something like this. Okay. So now this function exists in the in B, right? But it's also an interface. So here we can simply write b1 dot print display, right? And this will be able to print out b1. But let's take for another example. I have an interface. Let's say I call interface. This is going to be my type. Let's call I, right? Equals to b1, right? So in this case, I'm assigning b1 to the variable I, whose type is interface. And now, when you try to print out the I, right? You now see that I only has either a display or name. That's because I comes from the name or display. It does not have any other features. It does not have X, Y, and Z. It only has the features that are implemented here. And now I.display, right, in this case, does not actually have any implementation, but this implementation is already overwritten, it's already written in B, which I already have it here. So basically it will invoke this function, not this one, because this one only defines a header. The reason that we use an interface is to define all the header here, so that we can pull out the feature that we want to use. Okay, when you run it, you probably just see the same stuff as you see before. So you see a print keyword here. So that's an interface. The problem with interface is, remember that the problem with interface is that each member has to be public, right? They have to be public. They cannot be private. So you cannot, or they cannot be protected. They cannot be they cannot be like well, they can be internal. The reason is that this one, right? Obviously has to be internal because this interface is internal. And stream name has to be internal because this gets it from this internal, which means that so in this case, if you make it public, right, these two members are going to be public sized. But for interfaces, I don't think you can do this. Let's say internal. I don't know if you can. Oh yeah, you can. So in this case, we're actually making internal, and by here you can actually have this as internal method as well. Yeah, you can do that. So interfaces must have the same type as what we have here. Um, so it's like a lot of playing around with this stuff in order to better understand the syntax. Any questions on the interface? Hello? Huh? No? Okay, everyone's going quiet. I don't know, like maybe you're yeah, okay. Oh yeah, so this one actually gave you a syntax here, so this one has to be public. Yeah, so all the interface members have to be public. Okay. Now the last thing that I like to talk about, well, not quite the last thing, but I also like to talk about polymorphism. But I think polymorphism is probably best understood with an actual example. But for this one, we can still continue modify our class. Let's go back to A. Actually, you know what? Let's create well, let's create a new class then, because I think it's getting too many stuff here. So in this case, right, we have interfaces that only accepts public members, right? So now we have defined a class called X, right? But in this case, we want to make this an abstract class, right? And we can add a public here, right? So an abstract class is just like any class except it's abstract, which means that an abstract class, you cannot make an instance of an abstract class. Let's create another class called Y. Right, so this one is a class called Y, right? This is this is going to extend the X class. Okay, so let me just create a new program here. So add new item. Let's call abstract program. Okay, and then we simply do a public void static main, actually static void main. Okay, and then I need to set my property here. So abstract program here. Okay, now let me close this, and here we have a class. Okay, so in this case, if you start writing x equals to new x, right? This is going to give you a syntax error because you cannot create an instance of an abstract class or interface. And when I said abstraction, so let me remind you, like we have four principles that by the second test or the third test, you should at least know these four different principles. So the first four OOP principles. So first one is called encapsulation. First principle is encapsulation. This one means that information hiding information hiding. So it means that basically for all the information that you you should not be exposing them, and you should not like some of the information are critical that you should at least make sure that they're either read-only or cannot be modified by an outsider. And also some information should be hidden, like password. You don't want to expose that information outside of the class or instance. So those are the points I typically check when you deal with OOP test. These are the four principles that I think everyone should at least comprehend and able to apply correctly. Second principle is inheritance, which is what I cover, right? You have to inherit correctly. Third principle is what we call abstraction. This one is either what we call abstract class or interface. Either one will be okay, as long as you can show me that you understand how to apply abstraction. And number four will be the polymorphism, which means that you're making one type into another. So one typical example is here, right? So this is polymorphic because you're making type B into type A here, and typically you can do so by defining like by typecasting it. So for example, if you typecast in this case, right, to interface. So when I typecast the B1, right, as interface, right, then this will get you something else. It gets you display and name. It does not get you anything else. A lot of times you may want to also consider consider using base I guess base class. Well, consider using or making use of the one with the least amount. Well, I guess I don't know how to say that. Don't. So basically, don't use. Well, the type. Use the type that does not do more than what you need. Yeah, so basically so actually that's good. So use a type that does not do what more than what you need. So it means that like for example, if you only, like for example, if you have an employee, right? Employee salary has name, has email address, right? And let's say you only need to get the name, right? And the employee actually extends the person, right? And the person has a name, right? And in the method that you only need to get the name of the employee, right? Obviously, it's not a good idea for you to pass the employee as an employee type into your method, because you don't really need like more features. You don't need a salary feature. You don't need any other stuff that relates to employee. All you need from that method is the name. So in other words, all you have to do is to pass the employee as a person type into into the method that you're creating, and it will work fine, because in that case, doesn't have to, like, a student can also use your method, because the student extends the person class and it has a name. Otherwise, you have to create like multiple methods with multiple types that only fetches the name of the employee, of the student, of other people. So that's a recommendation that's generally made. Don't use more than what you need. In this case, we have actual display here. So when you run this function, it will actually just display your print the word display here. So going back to abstract class, an abstract class can do pretty much just about everything that a concrete class can do. A concrete class doesn't have keyword abstract. So in other words, it can implement. So it can construct. You have constructors, usually protected constructors. So for example, you can have protected this, right? When I say usually protected, if you define, for example, if you define public, this means that this constructor is not going to be public for a reason, because since you cannot create the instance of X directly, this is not going to be public. It's still going to be protected. Because in order to create an instance of an abstract class, you have to create from a concrete class Y. So this will be this will always be protected here. And everything is the same, so I'm not going to write anything else. You can also do the method. So in this case, I'll just call M, right? Method M. So in this case, I'll be calling method M. But you can also like create like like an abstract method, right? Let's say N, right? So in this case, I define as an abstract method N, right? In order to accomplish this, you have to like put the keyword abstract before the type. In this case, you're not actually defining the implementation here, because the implementation would now go into the concrete class. But the advantage of an abstract class is that this doesn't necessarily have to be public. It can be any other type, any other access for private. So it can be either public, protected internal, or internal. Right, so it can be either of these four different access modifiers. Obviously, it cannot be private, because if it's private, then how are you going to define the implementation? So you can protect it if you wanted to, but I'll just leave it be public. You can also like define a property that's called P, get and set. You can define the property with only a set, or with only a get, or both. you define this way, right? This means that this is a public, right? So you can also define as a protected string, abstract string get and set, right? Yeah. Yeah, it cannot be accessed, yes, but it can be accessed within the class. So for example, if you define this as abstract, public abstract string, so let me show you. Let me just implement this. So I simply just right mouse click. Let's do quick actions and then implement abstract class. And everything will be implemented. This one I'm going to replace it. By the way, when you overwrite an abstract member, you have to have a keyword override. And C# Visual Studio 2019 actually write this shorthand with the equals and then greater than sign. But usually you can actually just put like curly brackets. So I'm just going to replace all of them with curly brackets. Okay, so here we can also define a private, let's say string p. So in this case, I'm just going to return p here. What's going on here? Oh, sorry. So I'm going to return the p here. Okay, and then here I simply gonna put right, and then y dot p equals to the value, and this value, the p underscore p is gonna set to the value. Okay, so in this case, all I'm doing here is to just show to you like when you override a string p, right? You can set the value, and with a void main, right? With a void n, right? I'm simply going to write console.write. So in this case, I can always access this p, right? It's a protected, right? This one can be accessed within this class, or within the next class after extending the other class, right? So if I have public class, let's say z extending the y, right? So for example, if I have a public void display, right? In this case, I can simply do a console.write line. Let's say property is. So let's write $sign, and then we can write a p here. So p is protected property, but it can be accessed from z, right? Let's set n equals to p, right? P equals to let's say n here. Okay, so when you go back to your code, the abstract program, now this one obviously will not work, but if you define let's say z, right, new z, right? So now this one is going to have a constructor, right? Constructor is going to keep on calling the base constructor. What's going on? Did I get disconnected? My remote desktop is not working now. Yeah. Wait, what's going on here? It's not even working. Is everyone Wait, what's going on? Everything doesn't work that well. Yeah, let me just check. I don't know what's going on here. Yeah, my computer just doesn't work at all. Am I disconnected or what? No? I mean from YouTube. Huh? Yeah, for some reason it's not allowing me to click. Let me just reconnect it. But what? Huh? Yeah. Let me just reconnect my what's going on? I can't even remote. Oh, man. Just froze up. $280 MB. Let me just reconnect the stuff. Showing green screen here. Okay, cancel. Okay, I'm not sure what's going on here. Okay, so can everyone see? Yeah, I'm actually log on. It's a little bit slow. Not sure. Just double check this thing. Okay, yeah, it's kind of weird. Okay, I don't know why it froze up before. Does my speaker even work? Yeah, looks like it. Okay. Okay, so now we're creating a new instance of Z, setting into the abstract class, abstract instance of X. So in this case, we're going to print out. What are we going to do? Since we cannot access the P, right? This one we're not going to be able to access it. We can always call the N. So notice like N is actually defined as an abstract method in X, and it's not going to do anything. It's not going to call this one. Instead, since Y already have implementation of N, it will set the value of P to be N and then print out the value of Y. Now, since X is an instance of Since x is an instance of x, right, you won't be able to call it display function, but I like to call it display function to see my property. So I cannot call it display function right here, right? If I set it like z equals to x, right, this is going to give you a syntax error. The reason is that I'm setting a more specific type into a more I'm setting more general type into a more specific type. But in order to allow this, we have to explicitly typecast it to Z, because this tells that C# that you're going to do this unsafely. But since we created X from Z, this is actually okay. Whereas if you have another instance created from somewhere else, and you define a new instance, and you try to do it this way, it will not work, because the Z and the other instance may not be compatible. So there may be a compatibility issue problem. Okay. So now we can simply print out the display. We can actually just run the display function here. Okay, so when you run it, it's going to call this, and that will be also polymorphism plus inheritance and abstraction. So you can see that I'm actually calling x, right? So this function, there's a constructor here, the default constructor. By default, it creates like a parameterless constructor, calling the parameterless constructor of the base class, which is the y, and y doesn't have it, so y calls again a parameterless constructor in x, and x does have it, so therefore we're seeing bracket x here on the console prompt here. And next we have y.p equals to n, so that one is being created by simply having the x.n called. So x.n x is an abstract class. It's calling the n capital N, and this one is calling the n here. Saying the p equals to n, but p itself has more feature here. So this is gonna call the set value here, and then we're setting y equals y dot p equals to n, right? So that's why we see y dot p equals to n. Then we have then afterwards we're seeing the y dot n at the end, and then finishing up here, we're typecasting the x into z, and we're running the display. So display is going to call the p function, right? The p class, right? So property, yeah. So this one here we're calling the p first, right? So p is going to call the y.p first, and that's why we have a y.p here. Then finally, it's going to print out the property is p, which is essentially n. So that's how this program works. And then if you have installed Visual Studio, the class diagram, you should be able to add that as a class diagram. I might have it installed here. Hopefully it's here. Yeah. So you'll be able to add a class diagram, but let me show you my class diagram, what it looks like. Let's get rid of this. Class details, usually I think it's on the bottom. Okay. Okay, so here I like to add some class diagrams. So the way that it works is that I going to create a class diagram from these classes or these types I created, A, B, interface, and X and Y. So I just drag it here, and then automatically show you that Z extends Y, Y extends X, and X is an abstract class that defines P and other stuff. And likewise, we have an interface here, name and display. These are the italicized means abstract members. It shows you everything that you need here. It's messy here. I think there's a setting which I don't remember. Let me try this one. Okay, so this one looks a little bit better. So now we have all the features listed here. So class diagram is something that you can leverage in the exam if you're not too sure how your classes look like in terms of diagrams. And I believe that well, I believe you should install this package. It's I think I discussed that in the beginning of the semester. Questions here? It's already 3:35. No? So is everyone here? We're gonna dismiss soon because normally two and a half hours, 2 hours and 40 minutes. Yeah. So if you have any questions, I'll also look into. Let's see how to do this. Um. Yeah, you know what? Maybe the assignment which I wanted you to do, it's just gonna for you to go over the chapter. I know I did not cover like everything in the chapter, so one you can work on is the there's one I like this. Try to like go over this chapter, chapter 11, and this one gets extended to chapter 12. So go over the example, and then next week we'll be going over. So I want you to do this as an assignment. You don't have to try to be too stressed out on the assignments or ended up like uh, sharing codes with other people. But of course, I have codes here, so I want you to understand the concept as well as understand the syntax. That's the most important part, the syntax, and then also a concept. Why would they want you to have a commissioned employee written like this? You have commissioned employee defined all the common elements. You have the first name, last name, social security number, and so forth. And then this is actually just a single structure on the commissioned employee. And then later on, I want you to refactor it. So if you go over the example, they want you to like move everything, all the common elements into. I think they want you to move it to an employee class later on in this tutorial. And then you'll see like some of the elements should be moved up, and then you're adding, and then they want you to add something called a base plus commission employee, in which you add a base salary plus some math plus some calculations here, and just try to practice typing all those codes up. So that's chapter 11, and then also chapter 12. They added more stuff to commission employee. So that's all I want you to do for this week. Uh, I know it's been a very harsh semester this week, this semester. And how would you upload it? I probably just create what's that called? Like a Blackboard assignment folder, so you can just upload there. So the other one is the chapter 12. So just chapter 11 and chapter 12. Just work on commission employee. I think later on they introduce a simple interface on iPayable. Yes, like the invoice and employee. So these are actually an example they want you to work on. I think chapter 27, 28, that one has a much has a like a more I guess more realistic example in which we're going to use OOP to design and develop like an ATM machine. So we'll be looking at that example in the next class. In fact, I believe 2 classes. Yeah, so they talk about like wages, and these are something you can practice, like hourly employee, extends employee, and just work on all the stuff. Chapter 12. Any questions? Oh, class diagram, and do you see it? If you don't see it, you have to install it. It's not installed by default. I think I might have instructions. Let me see if I have any instructions there. I'm not sure if I have any instructions. Maybe under GitHub or announcements. Maybe it's in the announcement. Yeah. So yeah, so search for class install. So this one, there's instruction. If you don't see it, then you do not install it. So just follow under GitHub git intro. I wrote down the instruction all the way in the beginning of the semester. So you do add new item, and this is 2019. I think 2017 might have it installed by default. 2015, 2013. Yeah, so if you don't see it, you have to install it. Well, you don't have to install it because I'm not going to use it that much, but it may help you understand class in terms of diagrams better. Any other questions? Oh yeah, I will. Just like this one, right? It's gonna be on YouTube and yeah. Any other questions? No more? So just work on the commission employee and invoice from chapter 11 and chapter 12. Just learn to understand how that works. Syntax as well as understanding the idea behind it. And let's see how that goes. So nothing else? Okay, well let me just disconnect it then.